Hello students, welcome to the microprocessor lecture series. In this lecture, we will learn instruction queue. In the instruction queue of 8086, to speed up the program execution, the bus interface unit fetches 6 instruction bytes ahead of time from the memory. These pre-fetched instructions bytes are held for the execution in a group of registers called queue. With the help of queue, it is possible to fetch next instructions when the current instruction is in execution. The queue operates on the principle of first in, first out. That is, first instruction which is in the queue will be first executed, so that the execution unit gets the instruction for execution in order they are fetched. The feature of fetching the next instruction while the current instruction is in execution, it is called as pipelining or parallel processing. In the case of jump and call instructions, when instructions are already fetched in a queue are of no use, because jump and call will run at a new address. Hence, these queue is dumped or cleared and newly formed by loading the instruction from new address which is specified by jump or call instruction. Is instruction queue example. So here we will understand how the instruction queue is useful for increasing the speed of the execution. So here we have a small program of addition. So here this is our program. Here the address and the program is saved at a address 2000. So at a address of 2000 there is one instruction called as move, which is used for moving the data from source to the destination. So here this is a move instruction. And operators are EL, which is a register, and 5, which is a immediate data or constant number. So at the next instruction 2001, there is an instruction called as add, and it is adding the EL content with 6. So the 5 is added with 6 and we will get the result as 11. So as we know, instruction execution has 3 steps: fetch, decode and execute. So it will fetch the instruction 1, that is, and it will access the address 2000, and it will access the location and it will read the memory. Then in the decoding stage, it will identify the instruction, which is the instruction out of the all instruction set, which is this instruction. This is a data move instruction, and it will identify the operator on which the instruction is operating. So here this is a move, and AL and 5 are accessed. And in the execution step, the data is moved from source to the destination. So the file is saved at the register AL. So in this way, first instruction get executed in the 3 steps: fetch, decode and execution. When the first instruction completes its execution, second instruction will start its execution. So fetch 2, in the fetch 2, it will read the next address, that is 2001. In decode 2, it will identify the instructions and operator, that is add is the instruction which is a arithmetic or addition instruction, and operators are AL is a register, and 6 is a immediate data, and actual execution is done. So actual execution, it will add AL with the 6. So it will add the AL with the 6. So in this way, second instruction completes its execution and result will be saved into the AL register. So AL will be modified by new value, that is 11 in the decimal and B in the hex. So this is the way the 2 instruction will execute without the instruction pipelining. If we add the feature of instruction pipelining, then fetching is done into the bus interface unit, and decoding and execution is done in the execution unit. So fetch fetch one, decode one, and execution one. So first instruction will fetch, then it will decode and it will execute. Then while the first is in the execute decoding stage, another will fetch in by the bus interface unit. So parallelly both things are done. And in the next step, for second instruction will go into the decoding stage, and first will completely execute, and at that time the third instruction will be fetch. So in this way the it will require less time for the execution than the previous pattern, that is without instruction queuing. So we'll see the standard diagram of instruction pipelining. So the instruction pipelining. So the time required of the for the execution of two instruction without pipelining. So here sequential phases, phase one, then decode one, execute one, then phase two, decode two, and execute two. So this is the execution without pipelining feature. But with the pipelining feature, phase one, phase two, phase three are done in the bus interface unit, and in the execution unit, decode one, execute one, decode two, execute two, then it will take decode three, execute three, and so on. So here the time required for execution of two instruction because of pipelining will be less than the pipelining, because this feature is possible because architecture has a two separate part: bus interface unit, which is used for memory accessing, and execution unit, which is used for decoding and execution. And this is called as the overlapping phases of the instruction execution. So this is all about the pipelining feature of 8086. Thank you.